Alright, grade 11's question 3 of June 2017, paper 2, your trig functions question. So we are being asked, for question 3.1, to draw the sketches of the given graphs. So the given graphs, 2 cos x plus 1 and 1 minus sine x. So let's just talk about what's happening here. They're giving you, from the original, y equals a cos b x minus p plus 1. So when you're working with that, you've got to be able to recognize that here the amplitude has changed. It's now 2, it's normally 1. So that is the top of the graph, the bottom of the graph. The distance from the midline of the graph up to the top. They've also said to us here that we are adding 1. So we are shifting the graph up by 1 unit. So that amplitude, if our original graph is going to sit at 1 and negative 1, this amplitude is going to be stretched to 2 and negative 2, but also that is then going to be shifted up. So the 2 is going to become a 3 and the negative 2 is going to become a negative 1. All right, and then with your sine x graph here, it's supposed to be y equals sine x on its own. This now has become y equals negative sine x, which is a reflection. Goes from this graph to this graph. So it's a reflection in the x-axis. As well as now we are adding 1. So that's what I've just done, is just rearranged it a little bit there. So we are reflecting the graph and then shifting it up 1. So that's going to end up being at 1 and negative 1. But we're going to shift the graph up by 1 point. So that turning point is going to go to 2 and this one's going to go to 0. Okay, so for graphing, if you know your original graphs, then you can just shift them this way, upwards, downwards, left, right. But if you're working more comfortably with a calculator, then you are welcome to work with the calculator, plot it, but then just make sure your steps are right. So you go into your function part of your calculator, and where it says f of x, you're going to type in 2 cos, and then it opens a bracket. You're going to go alpha, close bracket, so alpha x, and then close the bracket after that, and then plus 1. You have to type it in properly. Then you're going to find all the numbers for the x's that have nice f of x's, nice y values. So they're going to ask you what you're going to start at. You're going to start at negative 90, and you're going to end at 360. Then the step is going to go up in as small an increment as you can. So if you can go up in 15s, then go up in 15s. If you can go up in 30s, then go up in 30s. But often if you put it in too small of a scale, then the calculator says insufficient memory. It doesn't have enough information for that. Also, they've said here that there's an answer sheet. So there is no answer sheet here on this video, but in an exam, when you're given an answer sheet, they normally give you the scale that you should go up in. So the scale goes up, that's your steps. So if it goes 30, 60, 90, then that's the steps that you're going to go up in on your calculator where it says steps. So in this case, the best one is going to be 30 degrees. So then you're going to start at negative 90, and that gives you a nice value of 1 for your y value. Negative 60 gives you 2. Negative 30 gives you an ugly value, so you're going to ignore it. 0 is going to give you 3. 30 is going to give you an ugly value. 60 is going to give you 2. Then 90 is going to give you 1 again. 120 is going to give you 0. 150 is not, it's a decimal, we don't want to use it. 180 is going to be negative 1. And it goes on like that. And that's how you're going to plot it. You would do the same for the sine graph as well. So just moving on to what the graph will look like if you plot it, you end up having 120 and the 0 that I spoke about. You have your intercepts over here. Please mark them clearly. You must stop at negative 90 as the graph has said, and you must stop exactly at 360 as they told you. Show very definitely your points of intersection. The purple graph ends up being a turning point at 90. This is your G, that's your F. So the red graph is going to be your cos graph, and your purple graph is going to be your sine graph. Use your calculators, it does help. All right, moving on to 3.2, it says write down the amplitude of f. Now you can look at the graph and see what the difference is between your peak and your minimum, and divide it by 2. So there's 4 units between them. If you divide it by 2, it's going to be 2. So the distance between divided by 2, that's where it's going to be. But also you can just look at the number in front of the cos, the sine, the tan. That gives you the amplitude. So in this case, the amplitude of f is positive 2. All right, the last question here is quite a sneaky question. It's for 6 marks. It says determine the values of x for which f of x is minus g of x equals 0. Now, take the g of x over. It becomes positive. They're asking you, where are your 2 graphs equal to each other? So where do they intersect? Or cross each other. Right, so having a look at the graph, where do they cross each other? This one's a bit deceiving. If we zoom in a little bit, you can see that is definitely not quite on the axis. So it's somewhere just before 120. That's 120 there. As well as over here, it's somewhere in the zone of negative 60. So we've got to have a look at how we're going to solve this. Now we're going to have to do it algebraically, and when we solve algebraically in trigonometry, that's a general solution. So we're going to have to find the general solution formula for this. Alright, so if we get back to this page where we end up with putting the graphs equal to each other. If I were to take my 1 across, that's going to cancel out. It'll be 1 minus 1. Alright, so here we are working with a cos and a sine of the same angle. When it's cos and sine of the same angle, you've got to change it to a tan. If it was cos and sine of 2 different angles, then you would have to change it using a co-ratio. Now, when it's 2 different angles, it can be 2x and x. Those are different. But when it's cos x and sine x, it doesn't matter what's happening before or after. You're using tan. So we're going to divide by cos on both sides. And so that's going to become 2, the cos's cancel, and this is going to become negative tan x. Now, you're only allowed to do this when you are changing to a tan. You're not allowed to just divide by a variable. Cos x is a variable here when you're solving, because then you lose the solution. Here, it's been worked into the tan. It's still there. The sine and cos are still there. So we're then going to take the negative across, and we're left with tan x equals negative 2. Alright, so in your calculator, you're going to say shift tan of negative 2, and it gets you negative 63,43 degrees. Because we've dropped the tan, we have to say plus k 180. K is an element of integers. So the first point that it's intersecting is going to be at x is negative 63,43. Then it's going to intersect if we move another 180 degrees backwards into the negative, or 180 degrees forward. So if we go back to the diagram, we can see that this point over there must be 180 degrees from the negative 63,43. So that's our first point of intersection. So we're going to move 180 degrees. If we wanted to see the next point, we move another 180 degrees. If we're going to see the next point, we're going to move another 180 degrees. If we want the one before, we go backwards 180 degrees. So it's going to be negative 63,43. It's going to be that plus 180, which is 116,57. And it's going to be that plus another 180, which is 296,57. So if we're allowed to go beyond negative 90 and positive 360, we could keep adding or subtracting the 180 until we get the numbers where they cross. So these are the specific solutions that we need for 3.3. And that is the function. So they do build in the general solution, slightly harder ones, into the functions a lot of the time.